and welcome to the Team 3 Knowledge Primer, where we explore how technology isn't just about hardware and code, but rather how it's profoundly shaped by human behavior, societal priorities, and economic forces. In our analysis of 4 exciting chapters, our team attempts to reveal how hidden project complexities, exclusion in computing, the push for a good life, and the global stakes of geoengineering each underscore one key truth. Successful innovation demands that we blend technical insight with ethical, cultural, and financial awareness. Next slide. I'm Ryan Miles, and I really enjoyed how Chapter 19 illustrates how even a simple, seemingly simple, engineering task like building a shielding wall at CERN reveals surprising complexity. It's never just about technical specification. It's about navigating people and power structures and real-world constraints. That is the essence of socio-technical complexity. Next slide. I observed this firsthand throughout my career, both while in the military and in industry. Architecting a secure global network or creating an extensible data framework wasn't just code and diagrams. It required bridging priorities, building trust, and adapting as constraints surfaced. My takeaway? Success emerges when we balance people, process, and technology. Embrace that complexity, and your efforts will thrive. Now I'm going to turn it over to Senji for the next part of the discussion.
Thanks, Ryan, for setting the context. My chapter, Winning is Losing, Why the Nation That Invented Computer Lost Its Lead, is quite an interesting one. Next slide, please. It was the year 1944, the World War II time, and the men were at the war. Women took up the responsibility in driving the computing industry in UK, and UK quickly became a leader. But when the war ended and the men came back, the women got pushed out. The government policies also did not do enough to recognize the critical role of inclusivity and stifled innovation and competitiveness. Next slide, please. As a result, we saw that systematic devaluation of women's contribution led to critical labor shortages. Failure to adapt to social changes hindered the technological processes. Disconnect between innovation, policy, and industry impeded the sustained growth. This case study of Mark Hicks' analysis of the British computing industry serves as a stark reminder of how social inequalities can directly impact technological leaderships and economic competitiveness. Next slide. Last year, during my research work for the master's course, I did get an opportunity to work on the DEI program of multiple large companies, and things haven't changed much. In the Bay Area, in the computing industry, the women participation is still less than 30%. I believe that by bringing in collaboration in technology, by valuing the diverse perspectives and importance of inclusivity, we can get back to a good participation from the women workforce. I will now request Mark to take over for his chapter. Thank you.
Thank you, Sanjeev. Very interesting. My name is Mark Alseguer. I'm a student in the Tech program. I'll be sharing the shaping technology for good life of Gary Chapman. As a technologist, indeed Chapman and contrast the technological imperative, which prioritizes innovation efficiency, with the social imperative, which indicates human well-being and ethical considerations. He also insists on balancing innovation with ethical social concerns. Next. He argues that technology should be shaped to enhance the good life rather than being driven solely by market forces or technological momentum. Next. Again, as a technologist, I definitely can understand the conflict between technological and social imperative. Chapman considered depends on how we integrate technology, society, and technology and economics. Next. Ultimately, he advocates balancing these imperatives, ensuring that technology advancements align with social values and needs. He finally concludes by saying that ethical governance and public engagement are vital for our society. Jose, I'm going to pass it to you to continue.
Thank you, Mark. For geoengineering, there are two approaches discussed in this paper that I wrote. Carbon dioxide removal captures CO2 from air using trees, machines, and ocean processing. It is then stored underground to reduce global warming. Soil radiation management, specifically a process called SDI, injects aerosols in the atmosphere to reflect the sun's rays and cool the planet. This brings unintended consequences because it can weaken monsoon systems, which leads to droughts and other more complex matters. No global regulation has been made pertaining to SDI. Many scientists focus on feasibility rather than long-term impacts on the current environment. This is dangerous, and there needs to be more public participation and global oversight because geoengineering has long-term and permanent impacts to our ecosystem. And in conclusion, there are technology which must be balanced technically, socially, and ethical considerations. Embrace diverse contributions, involve the public in decision-making, and encouraging global collaboration to tackle shared challenges. This concludes our presentation.